Make sure you have lesson 9596 out. You're going to be filling out the notes in the packet. So the very first thing you're going to do in the packet is you need to open up your textbook to page 442. But even if you don't have your textbook, this lesson will take you right to it because you can actually go and just look at it right here in the video. So you're going to answer these 4 questions and fill it into this worksheet. And when you're done with that, continue by watching the video. So here's the answers to when am I ever going to use this on page 442. Please check and see if you can make sense from the answers and compare it to yours. Next, we go on to measures of variation. And this is one of the measures of variation we're going to use our range. So looking at this data, this is basically looking at different fruit juices and how many calories they have. The first question says, find the range of calories. The range is simply the highest minus the lowest. So the highest number of calories that I have in here is 180 calories from prune juice. And the lowest is 35 calories from tomato juice. You have to find the difference by simply subtracting them. 180 minus 35. That gives us 145 calories. The range of calories is 145 calories. Now I need to write this data in the order from least to greatest because I'm going to need to do that to find the median and then the upper quartile and the lower quartile. So I'm going to go, you go ahead and do that, and when you're done, compare it to my answer. Okay, so now I have them all in order: 35, 80, 100, 110, 120, 120, 170, and 180. Now I have to find the median, which is the middle one. This one has an even set of data, so I've got 4 on the left and 4 on the right. So right in between those, right in between the 110 and the 120 is my median. It is actually the average between the two 110 and 120. And that is 115. So, and actually I can basically do that by taking 110, adding to 120, and that gives me 230, divide that in half, and I get 115. So the median of that data is 115. Now I'm going to break the data into 2 different groups separated by the median. So if I'm going to draw a big line here right through between 110 and 120, that is where my median is, 115. Now I have the 2 sets of data, 35, 80, 100, and 110, which is sort of my lower half of the data, and my upper half of the data, which is 120, 120, 170, 180. And I'm going to basically look at just each of these halves individually. So if I look at this half, bottom half of the data, 35, 80, 100, 110, I want to find the median of this data. Well, I've got 4 pieces of data. I've got an even number. So we've got 2 on the left, 2 on the right. Right in the middle, again, is another median in there, or actually that becomes my lower quartile. So halfway between 80 and 100 is 90, or another way of thinking about the median there is add up 80 plus 100, that's 180, divide that by 2, that gives me 90. So my median of the lower half is actually 90. All right, so I write that in there. The median of the lower half is 90. That's called the lower quartile. So that lower quartile is right there. It basically is showing me a quarter. A quartile means it's basically a quarter of the data is on the left-hand side. Another quarter of the data is here up to my median. Now I've got to break the upper half into quarters as well, or into halves so that the whole thing is in quarters. So again, I've got 4 pieces of data, 120, 120, 170, 180. I've got 2 on the left, 2 on the right. Halfway between is the median of that data, which is actually the upper quartile. All right, so halfway between 120 and 170, once again, I add those 2 numbers. 120 plus 170 is 290, half of which is 145. Okay, so now I have my lower quartile is 90, my upper quartile is 145. And actually, in between those 2 numbers, 50% of my data is in between those 2 numbers. And actually, I'm going to call that the interquartile range. It's the range between those two quartiles, and to find that, I just need to subtract 145 minus 90, which gives me 55. So 145 minus 90 is 55. That's called the interquartile range. Okay. All right, let's go ahead and do that on some other data here on the next one. All right, we've got some more data. Now, the nice thing is this one is already lined up in order. In this case, we're looking at some chocolate sales in the billions of dollars for various countries. U.S., of course, eating the most chocolate or selling the most chocolate in it. And so we have, nice thing about this data is it's already in the order, because in order to find the median, the lower quartile, and the upper quartile, we need to put them in the order. They're already in there. So see if you can use what we just learned in the last one to do this one on your own, and then compare with what I have. Just one slight difference in this one. This is an odd set of data here, which means the very middle one, in fact, Russia here, is going to be the median. We have 1, 2, 3 above that 4.9 and 1, 2, 3 below it. There's an odd number. So we don't actually have to take the average when there's an odd number. That becomes the median right there. Go ahead and try that on your own and see if you can find the median, lower quartile, upper quartile, and the interquartile range on your own, and then check it with my answers here. So I found the median to be $4.9 billion. The lower quartile, which is the middle of these three pieces of data, is $2.1 billion. The upper quartile, which is the median of these three upper pieces of data, is $6.5 billion. And since the interquartile range is the difference between the lower and the upper, I do the 6.5 minus the 2.1 to get $4.4 billion. All right, now I'm going to use this interquartile range and the data here to help me find any outliers, which is basically any data that sort of stands out and doesn't really fit in with the rest of the data. It's kind of like the data that doesn't really belong in the club. Is there any data that just really jumps out and doesn't really fit in? That's what the outliers is. So we're going to take a look. We're going to basically, there is a mathematical way of calculating whether something is an outlier or not. And basically, we take that interquartile range. This requires a little bit of memorization and practice to be able to get this down. It's not that hard if you practice it a few times here. But once you've found that interquartile range of $4.4 billion, you have to multiply that number by 1.5. So the way this works is basically to find out which pieces of data don't belong in the club, we basically take that interquartile range, which is the middle 50% of your data. And it's going to say we're going to expand that by 50%. And so it was $4.4 billion as our middle 50% of our data. We're going to multiply that by 1.5 or increase it by 50%, and we'll get $6.6 billion. And we're going to be pretty generous. We're going to say, let's take your lower quartile, and we're going to subtract 6.6 billion. So 2.1 billion minus 6.6 billion actually gives us a negative number, which is negative $4.5 billion. So in other words, if something is less than negative $4.5 billion, it doesn't belong in the club. It's an outlier. But there is going to be no country that has sales of less than negative $4.5 billion. So there's nothing on the lower side of this data that could possibly be an outlier. But let's try that in the opposite on the upper quartile. Now this time we're not going to be subtracting. We're going to see if there's anything bigger than that. So if I take $6.5 billion and I add that $6.6 billion to that, that actually gives me $13.1 billion. Anything that is bigger than that is not going to be in the club. It's going to be an outlier. Oh, and look at that. The United States is an outlier, because 13.1 is the limit for deciding whether something's an outlier or not. We basically took the upper quartile and added that interquartile range times 1.5, and we got 13.1. That was our limit there. This is above 13.1. This is $16.6 billion, which makes it an outlier. So a quick review here. Multiply the interquartile range 4.4 billion times 1.5 to get 6.6 billion. Subtract that from the lower quartile, 2.1 minus 6.6 gives us negative 4.5 billion. That's the lower limit for the outliers. Anything below that is an outlier. And we also take that 6.6 billion and you add it to the upper quartile, 6.5 plus the 6.6 billion. It gives us 13.1 billion. That is the upper limit for the outliers. Anything bigger than that is an outlier. There's nothing smaller than the lower quartile or than the lower limit for the outliers, but there is some data that is greater than the upper limit for the outliers, which means, yes, there is data outside those two limits, and the outlier is $6.6 billion. All right, let's go ahead and try another one here. If you can try to do this one on your own again, and find the median, lower quartile, upper quartile, interquartile range, and any outliers for this data, then we're going to do a graph of this after that and create a box and whiskers plot. But go ahead and put this data in the order and find those items first, and then we'll check and compare it to mine. So I found my median to be 52, and then halfway the median of my lower half of my data is 48. That's my lower quartile. The median of my upper half of the data is 61. That's my upper quartile. And then if I subtract 61 minus 48, I get 13. That's my interquartile range. Multiply that by 1.5, and I get 19.5, which is what I subtract from my lower quartile to find 21.5. Anything less than that will be an outlier. And I take that 19.5 and I add it to my upper quartile, which is 61, to get 80.5. Anything bigger than that is an outlier. I don't have anything bigger than 80.5, so I have no outliers in the top of my data. But I do have a number less than 21.5, which is 15. So that data is actually my only outlier in this set of data here. So now I'm going to create a box and whiskers plot based on all of the data that we've gathered from before. And all the numbers. We have the lower quartile, the median, the upper quartile, and we know the outliers. And we have all the information we need to create a box and whiskers plot. The first thing to have is a number line. A number line needs to include the lowest number of our data, which is 15, and it needs to include the highest, which is 67. That's included in there. I like to have more numbers in here on this to give a good scale of this on the number line. So you're going to need to draw out a number line like this first before you start drawing in your box and whiskers plot. So the first thing to think about, I just need three numbers, which are my lower quartile, my median, and my upper quartile. And I'm going to draw three vertical lines, the exact same size, parallel to each other. So my lower quartile is 48, so I'm going to go and find 48, which is right here. And I'm going to draw a line going straight up there. This is going to be the left side of my box, so I draw a vertical line using my computer, so this isn't going to come out perfectly for me. All right, and then I'm going to do the same thing in my median, which is 52. So I'm going to draw another line right at 52. Okay, not the perfect vertical line because I'm using digital on my computer, not that easy. And then my upper quartile is 61, so I'm going to draw another vertical line right there. All right, and now those are the left-hand side of my box, the right-hand side of my box, the two quartiles. The median is sort of a middle line that goes through the middle of the box. And now I'm going to need to draw the top and the bottom, which is just connecting the lines here. All right. And again, it's not that easy on a computer, but if you have a straight edge and a ruler, this should look a lot better than what I'm drawing right here. Not that easy to do on the computer, though. Okay, so I am almost done with, there we go. There's my box. So there's a box and whiskers plot. The box is done. It basically just tells me where the lower quartile is, where the median is, and where the upper quartile is. I actually have just drawn in 50% of my data that are in between the lower quartile and the upper quartile. Now I'm going to draw a whisker, which is a line that goes up to my highest point of my data that is not an outlier. I don't have any upper outliers here, so my upper data is actually 67. I'm going to put a a big dot here at 67. All right, and then I'm going to draw a line. This is my whisker that goes basically right to my data. There's my upper whisker, and now I'm going to do a lower whisker and the same. This one goes down to my lowest data point that is not an outlier, which is at 44. So I'm going to put a little dot there at 44. Not easy to draw a dot like this on a computer. There's my dot, and then that connects to, oops, that didn't work. Let's try that again. Here we go. Oh, it does work. Okay. All right, and connect that to my box. Now I have my box and whiskers. The only thing I have not put in there is a dot for my outlier. My outlier is 15, so I need to put a dot right at 15, and then I'm done with my box and whiskers plot. Okay, so there we go. That is everything on the data to create a box and whiskers plot. You need to know your lowest piece of data at the end of your left whiskers. You need to know the highest piece of data that's not an outlier, the right dot on the whiskers. You need to have the upper quartile, which is the right side of the box, the lower quartile, which is the left side of the box, and the median, which goes somewhere into the middle of the box. So just to be clear here, actually this box and whiskers plot tells me a lot about the data. Besides telling me what the median is, it tells me, for instance, if I start with my median, that 50% of my data is 52 or below, and it tells me that 50% of my data is 52 or above. I can also say that 25% of my data is between 61 and 67. That's basically the size of my whisker there. I also know 25% of my data is between 61 and 52. That's my upper, sort of the third quarter in here. The second quarter, also about a quarter of my data is between 48 and 52. And then the bottom quarter of my data, or less than 25, I know that 25% of my data is 48 or below, all the way down to the 15 there. So that is something, if I want to basically talk about percentages of my data being somewhere, this box and whiskers plot can really help me tell those things.